and Asha, Assistant Professor at LG Institutes of Engineering and Technology. So today we are going to discuss few more topics of multiple integrals. So let us start with a topic named change of variables in double integrals by Jacobians, right? So in some cases, evaluation of double integral becomes easier by changing the variables. Okay, let the variables x and y be replaced by new variables u comma v by the transformation x is equals to f1 of u comma v and y is equals to f2 of u comma v. That is, x will be in the form of u and v and y will be also in the form of u and v. Then double integration f of x comma y dx dy will be equals to double integration of f of f1 comma f2 into mod j du dv. After replacing this, our function will be converted into uv form, right? And this is Jacobian. So how to find the Jacobian? J is equals to del of x comma y upon del of u comma v, which can be written in the determinant of del x upon del u, del x upon del v, then del y upon del u, del y upon del v. You have to find the partial derivative and just solve the determinant, right? So now using this equation 1, the double integral can be transformed to the new variables that they are u and v. Now in sometimes the question is given in the form as u is equals to f1 of x comma y and v is equals to f2 of x comma y. Suppose our question is in this form, then what we have to do first is, firstly we have to find our j dash, right? That will be equals to del of u comma v upon del of x comma y. So this is just the reciprocal of j. So that will be given by del u by del x, then del u by del y, then you have to write del v by del x and del v by del y. After finding this, you have to find your j, right? That will be equals to 1 upon j dash. How we have written this? Because we know the identity, that is j into j dash will be equals to what? 1. Right? So after finding j, you can again use this formula, that is double integration f of x comma y dx dy. That will be equals to double integration of f of f1 comma f2 into mod j du dv. But firstly you have to find x and y from these two equations, right? And then use this formula. Okay, so now let us solve one example. So we have to evaluate double integration from 0 to 4 y by 2 to y by 2 plus 1 2x minus y upon 2 dx dy by applying the transformation u is equals to 2x minus y upon 2 and v is equals to y by 2. And also you have to draw the graph of both the regions. Okay, so now let us start with the solution. So you are given u as 2x minus y upon 2 and v as y by 2. So you are given of the form u is equals to f1 of x comma y and v as f2 of x comma y, right? So what we need to find? We need to find our j dash, right? That is equals to del of u comma v upon del of x comma y. That is written as del u by del x, del u by del y, del v by del x, del v by del y. Right? So firstly, let us find the derivative of u with respect to x, keeping what constant? Y as constant. So derivative of x will be 1 and 2 upon 2 will give us final answer as 1. Now let us find the derivative of u with respect to y, keeping this x term constant. So the derivative will be what? Minus 1 upon 2. Okay. Now we have to find the derivative of v with respect to x, right? So here y will be constant. but the derivative of the constant term will be equals to what? 0. And lastly, find the derivative of v with respect to y. So the derivative of y will be 1. So final answer will be what? 1 upon 2. Now just simplify this determinant. So you will get answer as 1 upon 2 minus 0. On simplifying, the last answer of g dash will be 1 upon 2. Okay. Now we know that j into j dash is equals to 1, right? So from this, what is our j? 1 upon j dash. So take the reciprocal of this, so you will get your answer of j as what? 2. Okay. So now dx dy will be equals to what? Mod j du dv. But our mod j is what? 2. So it will give us answer as 2 du dv. Okay. So now let us find the limits first. Now you are given that x varies from y by 2 to y by 2 plus 1, right? So now simplify this. That is cross multiply. So you will get 2x minus y as 0, and here you will get what? 2x minus y equals to 2. Okay, now we know that u is equals to 2x minus y upon 2, right? So 2u is equals to 2x minus y, right? So substitute over here. So what you will get? 2u is equals to 0 and 2u is equals to 2. From this you can say that u varies from u is equals to 0 to u is equals to 1. So we have derived the limits of u. So that is 0 to 1. Okay. Now our y varies from 0 to 4. This is given in the question, right? But we know v is equals to what? Y by 2. That is 2v will be equals to y. So we will substitute in place of y 2v. So what we will get? 2v is equals to 0 to 2v equals to 4. So finally our v will vary from 0 to v is equals to 2. So these are your limits of what? V. Right? So now we will draw the graph in both the regions, that is in our xy plane and uv plane, right? Now our lines given in the xy plane are what? X is equals to y by 2. That means y is equals to 2x, right? So first line is this. Next we are given what? X is equals to y by 2 plus 1. So this line can be written as what? 2x minus y is equals to 2, or we can write it as y is equals to 2x minus 2. These are your first two lines. The next lines are what? Y is equals to 0 and y is equal to 4. So now let us draw the line. Firstly, y is equals to 2x. So this is our line y is equals to 2x. Next we have to draw the line y is equals to 2x minus 2, right? Suppose you don't know to draw the line directly, then what you have to use? Our 10th standard method, that is you have to draw the box x and y. Now here you have to put various values of x. Suppose if we put 0, then y will be minus 2. Then suppose if you put 1, then y will be equals to 0. Next suppose if you put x as 2, then y will be equals to 2. Plot the points and draw the line y is equals to 2x minus 2. Okay. Next draw the line y is equal to 0. This is our x-axis, right? And lastly draw the line y is equals to 4. So the intersection of all these 4 lines gives us our region R in the xy plane, right? Now we have total 4 lines in our uv plane, right? And they are u is equals to 0, u is equals to 1, v is equals to 0 and v equals to 2. So draw your line u is equals to 0. That will be your v axis, right? Next draw the line u is equals to 1. Next draw the line v is equals to 0. That will be your u axis. And lastly draw the line v is equal to 2. So this region is our r dash and this is our new region r, right? So now the new integral will be of the form double integration over v is equals to 0 to v is equals to 2 and u is equals to 0 to u is equals to 1. Now we know this is equals to what? 2u, right? Du dv. Okay, now let us just integrate this firstly with respect to u. So the integration will be u square and the limits are 0 to 1, right? Now put the limits first, so you will get what? 1 minus 0, right? So what will only remain dv, and the limits are from 0 to 2. So just do the integration of this, so you will get v, right? And the limits are 0 to 2. Now on putting the limits, you will get your answer of the integration as 2. Okay? So now let us solve one more example. Here we have to evaluate x square plus y square dA over r by changing the variables, right? Where r is the region lying in the first quadrant and bounded by the hyperbolas x square minus y square is equals to 1, x square minus y square is equal to 9, xy is equals to 2 and xy equals to 4. Okay, so let us start with the solution. So you are given x square minus y square and xy, right? So what we will do, we will suppose x square minus y square as u and xy as v. So here too you have the form as u is equals to f1 of x comma y and v is of the form f2 of x comma y. So here too we have to find a j dash, that will be equals to del of u comma v upon del of x comma y. So this is written as del u by del x, del u by del y, del v by del x, del v by del y. Now we will find all the partial derivatives. So first partial derivative is with respect to x of u. So keep y as constant. So the answer will be 2x. Similarly, find the partial derivative of u with respect to y. So now this x will be constant. So answer will be minus 2y, right? Now find the partial derivative of v with respect to x. So we have to keep this y as constant, right? And the derivative of x will be what? 1. So answer will be y. And similarly find partial derivative of v with respect to y. So you will get your answer as x. Okay. Now simplify this determinant. So it will be equals to what? 2x square plus 2y square. Take out 2 common. So you will get answer as 2 times x square plus y square. Now using the properties of Jacobian, that is j into j dash is equals to 1, right? What we will get? J as 1 upon j dash. So it will be equals to 1 upon 2 x square plus y square. Okay. So finally our dx dy will be equals to mod j du dv. Just put the value of j. That is 1 upon 2 x square plus y square du dv. Okay. So now the region in the xy plane bounded by the curves x square minus y square is equals to 1, x square minus y square is equals to 9, xy equals to 2 and xy is equals to 4 will be transformed into a square in the uv plane, which will be bounded by the lines u is equals to 1, u is equals to 9, v equals to 2, v is equals to 4. Why we have written this? Because we have assumed our x square minus y square as what? U and our xy as v, right? So we have formed these 4 lines. Okay. So now let us draw the graphs. Firstly in the xy plane, then in the uv plane. Now if you are given your equation of the hyperbola as xy is equals to plus a square, right? Then it will be drawn in the first and third quadrant. Similarly, if you are given the graph as xy is equals to minus a square, right? Then the hyperbola will lie in the second and fourth quadrant. And suppose you are given the equation of the hyperbola as x square minus y square is equals to plus a square, right? Then our graph will be in our x-axis, right? And lastly, if x square minus y square is equals to minus a square is given, then the hyperbola lies over y-axis. Okay, so there are in all total 4 types of hyperbola. Here you are given first and the third type of hyperbola, that is we have to draw x square minus y square is equals to 9 and equals to 1, right? And we have to draw the hyperbolas xy is equals to 2 and xy is equals to 4. So xy is equals to 2 is drawn here. Similarly, we have drawn xy is equals to 4 and draw x square minus y square is equals to 1 and 9 over x-axis. So the total intersection will be this, and this is our region R. Okay. Now similarly, we will draw the 4 lines in the UV plane, right? They are u is equals to 1, then u is equals to 9, v is equals to 2, v is equals to 4. So we can see the region is transformed into a square. Okay, so now the new integral is double integration over r x square plus y square. Put your value of dx dy, that is 1 upon 2 x square plus y square du dv. Right? Now your limits of u are from 1 to 9 and limits of v are from 2 to 4, right? And these two gets cancelled out. Put your 1 upon 2 outside. So you have to, so now integrate with respect to u and v simultaneously, because here our given function is 1 only. So finally 1 upon 2 will remain as it is. Integration 1 dv will give us answer as 1 and limits are 2 to 4. And integration 1 du will be u and the limits are 1 to 9, right? Now just put the limits. So if you put the limits over here, you will get 4 minus 2 and in this you will get your answer as 9 minus 1, right? Now simplify this. So the final answer will be equals to what? 8, right? So in today's session we have studied to change the integral by using Jacobians, right? So what we have studied, double integration over r f of x comma y dx dy can be converted as double integration over r f of f1 comma f2 mod j du dv, right? Where our x will be equals to f1 of u comma v and y will be equals to what? f2 of u comma v. And your j will be given by del of x comma y upon del of u comma v. So which can be written as determinant of del x by del u, del x by del v, and del y by del u and del y by del v. So firstly you have to find j, then write mod j and then simplify the new integral. Okay. So I hope you have understood throughout the session. Thank you for watching.